Hello, 6th grade, and welcome to the first video for many of you of the year, which is going to be on section Endpoint 5, which is on factors. One of the big concepts in here is what we call the greatest common factor. Frequently, you'll see that written as GCF for an acronym. The big part of this that I think confuses people is common. Common, when we're talking about anything, means that there are traits that either people or numbers share. So when you're talking about GCF, you're talking about factors that two numbers share. So and to really point out that topic, you have me down here on the bottom left, and you have in the middle LeBron James, the best basketball player in the world. And I wanted to talk about some of the traits that we have in common to talk about what that number is. So I listed a couple traits here that I think LeBron and I are definitely in common. We are both definitely going bald. LeBron actually went bald even quicker than I did, which is very sad for him. I would say that we're very highly respected, especially inside of each of our professions. We are both very athletic. LeBron obviously is good at basketball. I'm good at everything, so that evens out there. And then, of course, we are insanely rich. His last contract earned him about $18 to $19 million a year. I'm on a teacher's salary, so we're both obviously making bank. So when we're going, before we can get to greatest common factor, I want us to just work on finding all of the factors of a number. And when we're trying to find all of the factors of a number, that means that every number that can divide evenly into 60. And I like to make them as pairs. So here I would say that 1 times 60 is equal to 60. Therefore, both 1 and 60 are factors of this number. I also know that 2 times 30 is equal to 60. So I know that 2 and 30 are both factors. And I'm hoping you're seeing one of the problems over here is that my list won't go in order. If you would like to, you can always rewrite it in order. I know that 3 times 20 is also equal to 60. So the numbers 3 and 20 also make the list. I know that 4 times 15 is equal to 60. So the numbers 4 and 15 equal. 5 works as well. 5 times 12 is equal to 60. I got to be running low here pretty quick. 6 and 10 is equal to 60. And as you see, I picked a number that has a very high amount of factors. 7 doesn't divide evenly into 60, 8 doesn't divide evenly, 9 doesn't divide evenly, and we already have 10. Therefore, here is our list of factors. You could also write it as this. Both of these, I would say, are good answers to this question. So when I'm asking you to find all of the factors, I'm asking you to do what I did here on the top. Now, moving down here to the bottom, the other thing you'll hear is called finding the prime factorization of. And what that means is I want you to create a tree of factors, which I want you to find the prime numbers only. If you notice in this list, not all of these numbers are prime. So what you're trying to do is break it down into prime numbers only. When you're making a tree, I highly recommend picking the lowest possible numbers to start with, but you don't have to. So I'm going to show you that you can pick any number. So I'm going to do 4 and 15. 4 can break down into 2 and 2. 15 breaks down into 3 and 5. What this means is if I took these numbers here at the bottom and I multiplied them all together, 2 times 2 times 3 times 5, I should get my target number of 60, and all of these numbers are now prime. So my answer for this bottom one has to be written as a mathematical sentence or an equation, which is this. 2 times 2 times 3 times 5 is equal to 60, and that is our prime factorization. So I would like you to pause the video and try both of these. Here's what I got for the answers to these questions. The factor list for 81, I had 1, 3, 9, 27, and 81. You could have written it in the list, or you could have written it as the factored pairs, like I did here. Down at the bottom, I found the prime factorization of 81 is 3 times 3 times 3 times 3 is equal to 81. Over here on the right, 120, I picked a pretty cool number, has all of these factors, and the prime factorization is 2 times 3 times 4 times 5 for 120. So, if you weren't able to do either of those problems, please come talk to me and I will help you individually. So now that we've gone to factors, we are going to find the greatest common factor of two numbers. So what I would do for these is I like to start with the largest number, so 45, and I want to find every possible factor, and I write it in a little different way. So I know that 1 and 45 are both factors. I know that 3 and 15 are also factors, and I know that 5 and 9 are factors. So these are all the factors of 45. 30, I know that 1 and 30 work. I know that 3 and 10 work. And I know that 5 and 6 work. And if we break down the definition of our word, it's the greatest, so largest, common factor. Well, we have all of the factors here. So what is the largest factor that they share? Well, not 30, not 10, not 6. 5 it is. So the greatest common factor of 30 and 45 is 5. I would like you to try this one on your own, and then I will solve it together. So I, once again, like to start with the largest number. It's not incorrect not to, but I think it's easiest. So I go 1 and 80, 2 and 40, 3 doesn't work, but 4 does. 5 works, so 5 and 16, and then 8 and 10. Okay, so there are all the factors of 80. So then for 50, it's 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 does, 6 doesn't work, 7 doesn't work, 8 doesn't work, and 9 doesn't work. So there is our full list. So the largest shared factor between these two numbers is 10. One of the ways that you will see it written sometimes is GCF of 50 and 80 is equal to 10, which means the same thing as what we wrote above. So check the website for any problems, and make sure you ask me questions if you're struggling with any of this stuff.